begin with this real analysis problem. Gonna begin with the first question. Like that. Okay. Prove that Pex equal to 0 if only if x is in the closure of E. So, 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 let's see. Okay. Let n n. Okay. Let Zn and E so that Pex smaller or equal to distance Zxz smaller than Pex plus epsilon. Okay, so this and this is just the definition. Definition of what? Of distance, right? So now we use the real analysis trick. Let's take epsilon equal to 1 over n. Then we have distance xz smaller than Pex plus 1 over n. So for n goes to infinity, we get distance xz smaller than Pex, right? Then now we can solve the problem. So we suppose that Pex equal to 0. So we get a distance x over z goes to 0. So zn so zn goes to x when n goes to infinity. So that is the first way. The second direction, we want we suppose that x is in the closure of E. So there exists a sequence Zn n go to 1 to infinity and E so that distance of Zn x shows that distance Zn x goes to 0. So that mean Pex equal to 0. So let's do the second question. Okay. We're gonna use the int, right? This int. So we have that. We have that PEX smaller than distance of xy plus PEY. That imply that PEX minus PEY smaller than distance xy. We can enter sensing x and y, so we get this PEY minus PEX smaller than distance of yx equal to distance of xy. So 1 and 2 combined give absolute value of PEX minus PEY smaller or equal to distance of xy. Thank you.